Good afternoon to all. My name is Nitin Kumar, Assistant Professor, Mechanical Engineering Department, NGFCT, Palwal. Today, we discuss about the sliding contact bearing, types of sliding contact bearing, and a classification of sliding contact bearing and design of sliding contact bearing. So first, before we start sliding contact bearing, just small glimpse of small introduction about what is bearing uh, and what is the function of bearing. So we tell about that. Bearing is a machine element that permit relative motion between two relative elements, such as a shaft and housing, with provide minimum friction. Okay, that is called bearing. Now, come to the function of bearing. Bearing ensure the free rotation of shaft and also hold the position of shaft at correct position. That is the function of bearing. Now we come to the classification of bearing. Classification of bearing is depends upon many factors. One is the according to the direction of load support. According to direction of load, there is two types of bearing: radial bearing and thrust bearing. Radial bearing, the load act perpendicular to the direction of the shaft of the axis. In thrust bearing, the load act along the axis of the shaft of the rotation. That is the basic difference between radial bearing and thrust bearing. Now uh, another factor which is very important factor, according to the nature of contact, the bearing is classified into sliding contact bearing and rolling contact bearing. So in sliding contact bearing, also called plain bearing and journal bearing. Journal inside portion of the shaft is called journal, so that's why it is also called journal bearing. In sliding contact bearing, the surface of the shaft slides over the surface of the bearing. That is called sliding contact bearing. It is used in centrifugal pump, uh, large size electric motor, automobile, etc. Now come to the another rolling contact bearing. In rolling contact bearing, the uh, surface of the shaft and surface of the bearing are separated by a uh, ball or rolling element like roller. So the basic difference between sliding contact bearing and rolling contact bearing is that keys in sliding contact bearing, the surface of the shaft and the surface of the when in sliding contact bearing, uh, when the surface of the shaft, one surface slides over the another surface, resulting friction and wear and tear. So for reduce this friction and wear and tear, we use lubrication. We can use water, oil, or etc. We can use to separate the surface of the shaft and the surface of the bearing. That is sliding contact concept of sliding. In rolling contact bearing, we can in rolling contact bearing, we can separate the surface of the shaft and bearing by rolling element like roller or ball. That is the basic difference between rolling contact bearing and sliding contact bearing. Contact bearing also called anti-friction bearing because it has low coefficient of friction. That is why it is also called rolling contact bearing. This is the some idea about bearing, how it is classified. Now come to our main point: sliding contact bearing. In sliding contact bearing, in sliding contact bearing, hello, yes. So now come to the sliding contact bearing. In sliding contact bearing, we can tell about what is sliding contact bearing. The classification of sliding contact bearing depends upon uh, uh, factors, few factors. One of that is angle of contact. Angle of contact of bearing. If the angle of contact of bearing with the journal is 360 degree, that is called full journal bearing, and it is 120 degree, it is called partial journal bearing. So sliding contact bearing, according to uh, according to the angle of contact, we can classify it sliding contact bearing, full journal bearing or partial journal bearing. Now according to the thickness of layer of lubricant between the bearing and the journal, the sliding contact being classified thick film bearing, thin film bearing, and thick film bearing thin film bearing, zero film bearing. So thick film bearing is that type of bearing in which the surface of the shaft and surface of the bearing are completely separated by a thick film of lubricant. That is called thick film bearing. In thin film bearing, the surface of the shaft and surface of the bearing are uh, partially contact to contact with each other. There is a partial contact between the bearing surface of bearing and shaft. That is because it is a very thin film lubrication between the surface of the shaft and the surface of the bearing. Zero film bearing. In zero film bearing, there is no lubricant we are used. That is called zero film bearing. Now, thick film bearing is classified into hydrodynamic bearing and hydrostatic bearing. So, hydrodynamic bearing and hydrostatic bearing. The basic difference between the hydrodynamic bearing and hydrostatic bearing is that the surface of the shaft and bearing will be separated by lubricant, but in hydrodynamic bearing the concept is the self built pressure, inbuilt pressure is built so that it can separate the surface of the shaft and the bearing. But in hydrostatic, we create a pressure through uh, outside source like pump. That pressure, that source will create a pressure. So this dispatch or the water into between the surface of the shaft and uh, bearing lubricant. That is the main difference between hydrostatic and hydro bearing. Now come to the uh, now come to the Now we come to the design of sliding contact bearing. In design of sliding contact bearing, we have to know about some terminology. Without terminology, we cannot find out the we cannot calculate the design of bearing. So it is important part. So before we start designing, first कुछ term जो है वो हमें मालूम होने चाहिए. So ताकि कि हम इसकी डिजाइनिंग कर सकें. That is diametric clearance. सबसे पहले आता है first is come diametric clearance. It is difference between the diameter of bearing and diameter of journal. C is equal to capital D minus D, where capital D is the diameter of bearing and small is the diameter of journal. Okay. Now next come to the diametral radial clearance. So radial clearance is the difference between the radii of bearing and radii of journal. R minus R. R we can written that d by 2 and small r small d by 2. So d minus d is called C, means diametric clearance by 2. So we can written radial clearance is equal to diametric clearance by 2. Next come to diametral clearance ratio. It is the ratio of diametral clearance to the diameter of the journal. Eccentricity, radial distance between the center of the bearing and the displaced center of the bearing under the load. When the load is applied, the center of the bearing is displaced. So distance between the original center and displaced center is called eccentricity. It is very important. Minimum oil film thickness. It is the minimum distance between the bearing and journal under complete lubrication condition. It may be assumed by C by 4. Sometimes we can assume it C by 4. Okay. Eccentricity ratio, ratio of eccentricity to the radial clearance. Short and long bearing, if L by D ratio is less than 1, short bearing, or greater than 1, long bearing. So these are the some terms we can use which will be helpful for designing a bearing. Sliding contact bearing. Now, for designing a sliding contact bearing, the important term is coefficient of friction. Coefficient of friction will be identified by Mackey-based equation or Petrov equation. Here we use Mackey-based equation. This will be 33 upon 10 to power 8 Zn upon P dy C plus K. Z is viscosity and journal speed, P pressure, D diameter of journal, C diametric clearance, and K is constant. Value of K will be find out by design data book. Design data book is available for machine design. So here we use PhD design data book. So we can from design data book there is a graph. So we find out the value of K from that graph. Now next is critical pressure. Now next is critical pressure. The pressure at which the oil film breaks so that the metal contact begin called critical pressure. Critical pressure वो pressure है जब ऑयल फिल्म ब्रेक होना शुरू हो जाए, सो दैट सरफेस ऑफ बियरिंग और शाफ्ट के बीच में कांटेक्ट पार्शियली स्टार्ट हो जाता है, दैट विल बी कॉल्ड क्रिटिकल प्रेशर. We can find out, you can see in the screen the formula of critical pressure. We find out the value of critical pressure for different conditions. Summerfield number, it is also a dimensional parameter, and the formula will be seen in the screen. Okay, we can find out the value of Summerfield number through design data book also, and we also calculate by this formula. Now next is the heat generated. Heat generated, the formula of heat generated is Q barabar mu V W. Where mu is coefficient of friction, we use Mackey equation. We discuss about that. V is a rubbing velocity and W is the load on the bearing. Now next is what type heat dissipated by the bearing. It is denoted by CA minus TA, where C is the heat dissipate coefficient. The value of heat dissipate coefficient will be 140 to 420, and A is the projected area, B is bearing temperature, and A is ambient temperature. If bearing temperature is not given, then then uh, then the temperature of oil film will be given. For that condition, we can use TB minus TA की जगह हम 1/2 T naught minus TA को use करेंगे. Now for I will tell you about the value of C, heat dissipate coefficient. For unventilated bearing, we use 140 to 420, or ventilated bearing 490 to 1400. Means what type of condition is given to the design problem, we can use the value of C. That is the basic concept of uh, if we want to design the sliding contact bearing, we know about all these parameters, then we are able to design the sliding contact bearings problem. Thank you very much.